Hi, good morning. It's Gene from the Mavestar Observatory. In this video, guys, I just want to simplify something for you. So we're going to take it right back down to grassroots and make it so simple that even a child could understand what's going on and what to expect. And we'll talk about a few other things later on in this video because, you know, I've had quite a few comments in the comment section down below the videos saying, okay, we understand there's some changes and things are going to change dramatically on our planet within possibly the next 10 years, which could lead to, you know, over 1 billion souls that are with us right now not being with us in just 10 years time. So I'm going to try and simplify it so simple for you that, you know, you should have a clear understanding of where we are and what is coming. So before we begin, I just want to say it's the last day of the month. It'd be great if we could, you know, smash the target of what we raised for the observatory last month, and today's the only day we're going to be able to do that. So, you know, at the end of this video there'll be a link and you can support us if you want to. It's clearly up to you guys. It's entirely up to you. If you want to support what we do and our efforts at this observatory, the link will be provided. I just want to say thank you to all those people over the last couple of days that have chucked in a few pound to support what we do. So let's begin. We're looking at a chart which obviously has CO2 data on it, but we're not interested in that because CO2 is not what's changing our atmosphere and in turn our climate, regardless of the little amount we put into the atmosphere. And over a time period since 1760s, when the Industrial Revolution began, it is really irrelevant because, as you see on this chart, going back 425,000 years, there has been, you know, times where CO2 has risen, and when the temperatures have cooled, likewise the CO2 levels have dropped. So it's a natural phenomena. The Industrial Revolution certainly wasn't about 425,000 years ago, and, you know, mankind was not significantly on this earth in the numbers that he is today. So, you know, we're not going to really go into CO2 in this video. We're going to concentrate on the more important thing, which is the temperature. On this chart, I'm going to show you several other charts because you may have already spotted a trend. Now, I said I was going to simplify it, and just to give you an analogy and not to patronise you or sound condescending, please don't get me wrong. I just want to show you that even children as young as 4 years old can easily pick up on trends. So to give you an analogy, I've got two cards and a 4-year-old child in front of me. One card is blue, one card is red. I hold up the red card and I put it down. I'll say to the child, what colour card do you think I'm going to hold up next? He's probably going to go for either the red or the blue. But if I hold up the red card again, he's starting to think, why didn't the blue card get put up this time? So I put it down and I say, what colour next? He's probably going to say, well, it's time for a blue card. So he's going to say blue and get it wrong again. But I'm just going to keep holding the red card up, and eventually that child is going to select the red card because he knows that the blue card for some reason isn't being held up. It's as simple as what we're looking at with these charts and the trends. Now, you've probably seen the peaks where temperature goes up to, you know, 4 Celsius plus on there. You can see the peaks. Some of them are around 6, some of them are just below it. But what we're concentrating on is the interglacial periods where temperatures on the earth are slightly above freezing, and that is the difference between putting crops in the ground and getting some crops out, as opposed to living in a period of time like a glacial period where the ground is frozen, and as a result the vegetation doesn't grow above the ground because as soon as it does, it freezes, and things like, you know, staple foods like wheat, corn, potatoes and things like that just simply don't grow in temperatures like that, and we end up with glacial periods and interglacial periods. But you can see how sudden a glacial period can arise and how quickly an interglacial period can come along. But if you will note one thing, that glacial periods, times where temperatures are below zero, last a lot longer than these little peaks. And if we just go straight to the right hand side of the chart, we can see where we are at the point of zero. And you can see that the peak has already been had, and we are going back into another trough, which could quite easily put us back into a glacial period. Another thing is it's very difficult to get a trend out of this, because they don't exactly fall in line at exact times every time that a glacial period or interglacial period happens. But what we can denote from these charts is that the colder temperatures are around in the glacial periods for a lot longer than what they are in the warmer periods. So glacial periods are very common and long lasting, as opposed to warm periods on this planet, and that, going back over 425,000 years, is a natural anomaly that this Earth regularly goes through, as you can see. But the main point is where we are. Yeah. Now, if I showed a child this chart and said, well, you know, as soon as we get a peak like this, it drops off and we go back into an interglacial period, and then it warms very suddenly over a short amount of years, and then it drops off again and we go back into a prolonged glacial period. And, you know, here's another peak and it drops off rapidly and we go back into a glacial period. And here we are at the last peak on there at our present time. If I said to the child, what do you think is going to happen next? It's going to say, probably we're going to go back into a glacial period for a prolonged period of time. And that is exactly what this trend is showing us on this chart. Now, I said I was going to show you a few more charts, because, you know, the information is exactly the same, but we'll just see it in several different charts. But I'll just show you a few for examples. So here's another chart showing the same information. We can see the peaks in the chart, and we can see where we are at present day 0 right here. So obviously what is about to occur next is, you know, natural. It looks like we're going back into a glacial period, but, you know, all these charts show the same thing. Let's have a look at a few more. Again, in thousands of years we can see the same peaks in temperatures, and if we just go back to 0, you can see we're on another peak, and there's even a little bit of a forecast on here showing that the peak is, you know, going down into a trough again. But, you know, they all show the same thing. I'll just show you a couple more and then we'll move on to something else. I'll leave this as the final example. Just note that the ice volume on the lower column here is inverted, which means that the high levels of ice are at the bottom, and you can see where we are at the lowest level of ice. But every time we're at the lowest level of ice on here, you can see there is a peak, and after that peak it starts to build back up. So we can clearly see what's going to come next. We're on the line where we've seen, you know, many times before in our history, going back hundreds of thousands of years, what is on the cards to happen next. So it's clear. You could put your money on this if you wanted to, and you'd be a winner with this information. It's just a case of following trends to know what comes next. This is why scientists collect data, because we can forecast what is going to happen next. You don't need to be, you know, a solar physicist, a climatologist, or anything to do with science. All you need to do is, like the 4-year-old child in the analogy earlier, is just study the trends clearly. So okay, you tell me what you think is coming next. This is the last 3 solar cycles, and, you know, you can see what's happening. What do you think is going to be the next solar cycle? Is it going to be above solar cycle 24 or below? If you ask me that question, I'd say I'm going to follow the trend, because over the last 3 solar cycles they've been dropping off by nearly half every time. And if that's the case, then there's no reason at this point, at the end of solar cycle 24, to believe that the solar cycle could be stronger. I'm just going to go with the trend, and I'm going to say the solar cycle 25 might not even get started, but if it does, it's not going to be anywhere above solar cycle 24. It's going to be below it, because the trend shows that these drop off in 50% every time they come along to the present solar cycle 24. And if that's the case, then at the best we should have is, if we look at the lower projection of solar cycle 24 there was 50 sunspots. At the middle range there was 75, and at the peak or highest range there was 100. I'm going to go with the lower lines on all of these solar cycles, and I'm going to predict that there will be less than 25 sunspots, if any, in solar cycle 25. That's if solar cycle 25 gets off the ground. I've seen reports where this was predicted to happen in 2015. That was at this point here. Right, we're past solar maximum at 2015, and sunspots were projected to not even take place because of the increase in temperature of about 45 Kelvin in the umbra of sunspots, and that was what was enabling them not to form on the sun in the first place. So, you know, we have to put this in perspective. What does this mean for us if we're having a trend of solar sunspot activity drop off over 33 years? You know, we can project that the next solar cycles until we see equilibrium, which is equilibrium would be solar cycle 25 at exactly the same, or if not a bit better than the performance of solar cycle 24. That would be equilibrium, and we could then say, yes, we might start to see more sunspot activity. You know, it's very hard for organisations like NASA to manipulate sunspot data, because anyone with a reasonable camera and a filter over the lens can focus on the sun on a nice clear day and see sunspots for themselves. There is a bit of discrepancy in the way sunspots are calculated, and some sunspots, as they go around the disk, get recounted again. Did you know that? And that is not really fair play in science as far as I'm concerned, because if you've named it once, it's one sunspot, and it doesn't matter the duration of the time it lasts on there. You shouldn't renumber that sunspot just because it comes back round, and NASA should know better to do this, because they've got stereo A and stereo B satellites at the front and back of the sun, and they know that that is the same sunspot just coming back round, so there's no need to calculate that again. So what I'm saying is that these numbers of sunspots could be actually higher than what they actually really are, but you know, they can't manipulate it too much, because there are amateur astronomers out there that have got the ability to have a look at what's on the sun at any given day, and you know, it'd be very easy for them to be proven wrong. But you know, the point is here, there's a trend, and we can see the trend dropping off, and as a result of that, we shouldn't expect anything better than what we've seen already. In fact, we should go with the trend and say that it's likely that solar cycle 25 won't be as large as solar cycle 24, because we've seen no equilibrium or change at this point in time. So for now, things are going to continue the way they are. Now, before we move on, I just want to make one thing very clear to you guys, because something has changed with the last solar cycle that we've never recordedly witnessed before, and it hasn't been made public aware, so bear with me. Alright, what we're going to concentrate on is the cosmic radiation that comes in during the solar maximum and solar minimums. You can see that if we go back over the solar cycles, first of all, around 2015, as you saw on the last chart, was beyond solar maximum, so the solar cycle was starting to decay at 2015. But the important point is, right, that during that decay at solar maximum, as you can see, for the first time, we are still experiencing cosmic rays even during solar maximum. Now, if you look before that at solar cycle 23, during maximum, we don't have solar radiation cross that level of what we did in solar cycle 24. Usually during the solar cycle maximum, it is pushing out a lot more cosmic radiation than, you know, during solar minimum. At solar minimum, we always get a lot of cosmic radiation in, but just pay attention to the end of solar cycle 22, solar cycle 23, and then you'll see that as the solar cycles, in the troughs of the solar cycles, continue through solar cycles, what we get is an influx of radiation. It starts off here at the end of solar cycle 21. We can see that there's a moderate amount of radiation during the minimum period of the cycle, and then if we go to the next solar cycle, we can see that the amount of radiation even during minimums is, you know, increasing by twofold. But have a look at solar cycle maximums during these periods of times. It's never allowed it to come across that line. Where if we go straight to solar cycle 24, we can see the radiation is increasing still, even though the sun is at its solar maximum in solar cycle 24. So this is new territory, guys. And again, if we see the radiation doubling every time the solar cycle decreases, then we see another pattern and we know what to expect. We can forecast from this point on, just by looking at the solar cycle minimums during these 3 solar cycles. We can see that as time has gone on to the more recent date that we are at right now, or the present, we have incurred during each solar cycle more cosmic radiation. But even though we have endured more cosmic radiation during solar minimums, we are now moving into new territory, because it doesn't matter. As the solar cycles are that weak now, the heliosphere is not inflating to a protective point that we have experienced and enjoyed over the past years. So we're in new territory. We've got cosmic radiation inbound regardless of solar maximum. And if we just, like we have, studied the trends of the solar cycles and interglacial and glacial periods, we can make a prediction on this. We can say that the solar cycles are likely to continue to become weaker and weaker, and as a result, during solar minimums of the future cycles that we're going to experience, there is going to be more cosmic radiation, and as a result of that, weakening of the solar cycles, even during solar maximum of these next cycles that we're going to get, if they don't start to increase in significant numbers, we're going to even get cosmic radiation coming through more than what we had during solar maximum. And that, guys, is shocking news. This is, like I say, new territory. None of your solar physicists at either ESA have come out and told you this. No one at NASA has come out and told you this. No solar physicist of any independent research facility or observatory has came out, other than myself, and notified you of this. It is something to be cautious about. That's all I'm saying. And you can see from the trend that this is set to get worse. Now, what does all this mean? Well, what this clearly means is that as a result of a low solar output, our heliosphere is weakened and allowed more cosmic radiation in. And on top of that, we have the Earth going through a magnetic reversal, which is weakening, at this present time, the Earth's magnetosphere by 20%. Those two things allow more cosmic radiation inbound, and as a result we get busted jet streams that deliver unpredictable climate on this planet. And if we get unpredictable climate on this planet, it means that the seasons are not going to be regular. It means that farmers, who, even though they're experts on their own land and know what exactly they need to put in that ground to grow, are going to struggle from this point on out. And that means that, also as a result of this, and this is unclear science because no one of us know exactly what the whereabouts and the anomalies that lead up to the Earth going into a rapid cooling and possibly another glacial period. None of us were around and recorded that data over 20,000 years ago when this took place. So we don't know what to expect when it happens. So we've just got to, go on what we've got at the moment. We know we've got an increase in cosmic radiation. We know that the jet streams are no longer following their natural patterns, like having a polar jet stream at 30 degrees, subtropical jet stream at 30 degrees and at 60 degrees a polar jet stream, both over the northern and southern hemispheres. Instead, what we've got is a busted jet stream that sometimes appears that when we look at data like this from North Skull, that we only have 2 jet streams on this planet at the best of times. If I just spin the globe round, you can see the extent and condition of our jet streams on this planet. If I show you the northern hemisphere and then switch over to temperature, you'll see everything north of those jet streams is delivering sub-zero temperatures. I'll just put it back onto the jet streams again so you can see that. So anything within the central region of that jet stream that we can see is, as you can see, in sub-zero temperatures. And this is the same case for the southern hemisphere of our planet. Switching back to the jet stream. Again, inside this zone is the coolest part of the planets. So if our jet streams hang further towards the equatorial region, whether you're on the northern hemisphere or the southern hemisphere, and your continent lies in that ring of that jet stream, then you can experience in the future a lot cooler temperatures. And maybe, you know, this busted jet stream is the very thing that leads to cooling of the planet, which is a natural cycle which we call a glacial period. Now guys, it depends on exactly your latitudinal position on this planet as to whether you're in a glacial or interglacial period. Now there has been, you know, two places on our planet that are constantly in glacial periods, and that is the Arctic and Antarctic region, which is natural. But what's not natural to see is, you know, these Arctic temperatures coming further down towards the equatorial region or the tropics, and that is exactly what we're getting. And we know from studying glacial periods that they can come as low as 52 degrees latitude over the northern hemisphere, and that affects most of the countries in Europe. But if we're getting regular sub-zero temperatures at 52 degrees, then the region, you know, a good 20 degrees below that, so around 35 degrees, is going to experience the temperatures that we experience right now, and that's going to cause problems globally. And that's why I say, you know, what's coming in the next 10 years could quite easily lead to at least 1 billion people not being with us. This Earth, despite what people say, can just barely keep the amount of people at this present time functioning with the food, and we're already starting to see, you know, peak food production, if we haven't in some cases already seen that. You know, when we hear of the very first people slaughtering even their breeding cows, that's something to pay much attention to, because this is a crossover on the line. You know, if it's no longer sustainable because of you can't get water to your cattle, that you're going to lose it all, and so you might as well just get what you can for it. So you take the lot to slaughter. That means you lose, you know, those breeding genes, the genetics of those herds for a long period of time. You just don't simply gain that quality of herd back overnight. And it's the same for the crops, and likewise across many ranges. And for each of us it means something completely different, and that is because it all depends on your latitudinal position on the planet, and you know, what is going on locally in your region. You know, why don't you join me tomorrow, and I'll share a few ideas with you, what possibly could be a good idea for some of us, not all of us. Like I say, we're all our needs are different, but you know, we'll at least, you know, open the debate on talking about these things, you know, and I'll share a few ideas with you tomorrow in a video or something like that. So, you know, enjoy your weekend, guys. There's a link down below if you want to support what we do on this observatory. And again, I wasn't trying to be patronising or condescending in any way. I just wanted to, you know, point out the trends, because by looking at these trends we get an idea of what to expect next. It's a good forecast in method, if nothing else. So yeah, there's a link down there if you want to support us on this observatory. You know, it's the last day of the month. Let's try and beat what we did last month, because last month was just appalling. And I'll say what I usually do, guys. You have a great weekend. I'll catch up with you later. As always, bye for now.